The topic of this video is to give a little bit of introduction to energy and how it's going to be used in this particular course. So up to this point, we've been sort of used to dealing with objects, say like cars, that had the variables that we're all used to now, say some speed or velocity, however you want to think about it, going to the right, and it also has some position x. So it turns out that these variables are very important also in our considerations for energy. So now that we're used to, say, position and velocity, we don't have to, say, get rid of them or forget about them in order to start dealing with energy analysis of these problems here. So just a couple of words about energy here. As it turns out that energy is one of these things that are kind of hard to define. So if I ask a classroom of students about what energy is, typically they'll say something about maybe something like the ability to do work. And that's fine, and work is something that's going to be important that we're going to talk about in the consciousness of energy. This is very much a sort of textbook memorized definition. I'm not sure anyone really knows exactly what that means, or even if this definition has helped us to understand what energy is. So instead of understanding what energy is or trying to come up with a good definition of energy, instead it's actually easier to think about things that we can do with energy instead of understanding what it is. Because it turns out that no one really knows what energy is. This is a textbook definition that works in physics, but like I said, maybe making a list of things we can do with energy actually might help a little more. So we know, for instance, we can use energy to do things. We can lose energy. We can save energy. We can gain energy. We can waste energy. And the list goes on and on like that. So these are some of the things that we can do with energy, and we'll see these things happen in physics problems. So, for instance, like this car that's moving down the road with some speed v is actually using energy. And if the car starts slowing down, well, it's probably losing energy. When you leave the light on in your room and you're not home, you're wasting energy. You can also save energy, that kind of thing. So that's probably a better way to think about energy. So let's just see a couple more things here. The other thing about energy is it's definitely in the news a lot more now. Resource wars and oil and electricity and solar and things like that. So in the news and sort of more colloquialism, we think of energy in terms of oil and maybe nuclear and solar and things about coal and gasoline and these kind of things. But it turns out that in this class then, as interesting as these things might be, we're not really going to talk about these either, so we sort of have to X those out. We do need to just get some basics out, though, so before we can start worrying about the oil and the nuclear and the solar and the coil and things of larger issues about using and losing and saving and gaining and that sort of thing, and even this esoteric concept of the ability to do work, we just need to get some more basic fundamentals about energy out there that will allow us to stick with some of the basic problems that we worry about in a physics course like this. In particular, cars going down the road, like what would the energy analysis be, say, of a car going down the road. So let's just get right at it then. We'll dispense with any more of the philosophy or the societal impacts of energy and just get right at it. What does it have to do with physics? Well, what it has to do with physics right off is, as we get started, there's two types of energy that we'll have to be worried about in a physics course like this. The first type of energy is kinetic energy. Kinetic energy. And the second type of energy is potential energy. These are the two types of energy that are exclusively used, discussed, and useful in a course like this. So what do they mean then? Kinetic, of course, implies motion, and so this is the energy of motion. In other words, whenever something is moving or moves, it must have kinetic energy. That's just the way kinetic energy works. So if I can just go down here a little bit, scroll down just a little bit here, we'll sort of label kinetic energy. It's more convenient to just label it KE, something like that. And the definition of it is equal to 1/2, the number 1/2, times m times a v squared. This is the definition of kinetic energy, and it's a fundamental equation in physics, and it gives you the amount of kinetic energy something has. So what does it mean, though? Well, it means that if something has a mass and something has a speed, or a velocity, if you like to put it in the vector setting, if it has a mass and a speed, then it has a kinetic energy. So those are the only two requirements right there. So this term of kinetic energy comes from something having a mass plus a speed. Those are the only two requirements something has to have before you can say it has a kinetic energy. So for instance, if it doesn't have a speed, like it's not moving, if the car is at rest, then that means it doesn't have any kinetic energy, because if you put a 0 in for V, you'll get a 0 for kinetic energy. Or alternatively, it's moving, but it doesn't have a mass. Now, I can't think of what that is, something like a light or a photon or something like that, but there's other energies associated with that. Then it wouldn't have kinetic energy either. But we don't worry about massless things too much in this particular class here. So again, just keep in your mind that if it has a mass and has a speed, it'll have a kinetic energy. And the units of all of this stuff, if you just take something's mass, multiply it by its velocity squared, and by 1/2 here, you'll get some kinetic energy, and the units of energy are in joules. So you will get so much energy an object would have. So that's the first type of energy, exclusively kinetic energy, 1/2 mv squared. If it has a mass and it has a speed, it has a kinetic energy in joules, period. And kinetic energy is exclusively reserved for the energy of motion. If something is moving and it has a mass, then it has a kinetic energy. Okay, so the next type of energy is potential energy, and we'll have a few more things to say about that. And that's our next type of energy. Let me just make a little bit of room here, and we'll get on with potential energy. So potential energy, of course, the word potential here implies the word that it has some ability. Has ability. That's what potential usually means. So a student could have great potential, or an idea or an invention might have great potential, or a stock of a company might have great potential. That means it has some ability. In this case, because it's potential energy, it has the ability, I'll say, to do something. Now again, the textbook fans in the crowd there will sort of substitute this word something here with work, because potential energy does mean something has the ability to do some work, but this idea of work is kind of vague, and maybe we don't quite understand what that means either, although there will be a separate video exclusively on work because it is very important to us. So it has the ability to do something. Well, what that means is something like this. I'll just sort of describe this with an example. Here's the ground. And suppose up above the ground like this, I have a very big, heavy lead brick, some big thing that has a huge mass like this. Maybe it's made out of lead. It's incredibly heavy and very hard to hold up. So maybe it's a person standing here like this, and they're holding the brick up, and it's very difficult. Their forearms are shaking because it's so heavy and things like that. You could say that this brick here has potential energy. And why does it have potential energy? Because it has that ability to do something. Or if you're like in the textbook example, it has the ability to do some work. Now, what do I mean by that? What I mean by that, then, to do something, well, what we could do is, if this big, heavy brick is up here, we could put a little soda can right here, and right here, a little aluminum soda can that we just maybe finished drinking a nice cold drink on a hot day. And what we could do is then we could drop the block. We could drop the block on the soda can, and what it would look like when it's done is the soda can would be absolutely crushed like this. Just go over here. The soda can would be absolutely crushed. I'll just draw it as a thin red line like that, and on top of the soda can would be this big block. So here's the big block right here, just completely crushed. So what did that block do? It crushed the can. The can is now crushed. That's what it did. So in this particular situation here, we say the block has potential energy because it has the ability to do something. It isn't doing anything while we're holding it, but it has the ability to do something. What did it do in this case? When it was released and fell, what it did was crush the can. Now, as you might guess, it takes energy to crush a can because cans have some rigidity to them, and they're made out of aluminum, and you want to get it from the big shape to the small one. You have to crush the whole thing, and it took some energy to do that. So you notice a couple of things now. The can is crushed here, but you could say over here also that the potential energy block now is now zero. It doesn't have the ability to do anything anymore because it's on the ground. And that's the nature of potential energy. It has the ability to do something, and that something might be called work, but something in general in mind could be anything you can think of that maybe involves changing something or some action. So the something here really involves some kind of action or result. You'll invariably see something. When potential energy is released, you'll see something happening. A can will get crushed, a ball will fall, a car will go harder or faster or whatever it will be, but you'll be able to track that potential energy went into some result or action. The other type of potential energy I can just talk about, as long as we're talking about cars here, is like here's a car right here, and suppose that there's the gas tank in the back of the car like this, and the gas tank is full. So I'll just sort of draw the gas in this reddish color here, which it often looks like here. So here's the gas in a nice full gas tank right there. You could say here that if your gas fuel tank now reads full like that, so here's sort of a little gas fuel tank like this, and the needle's on full like that, the gasoline in the car is definitely potential energy because it's just sitting there, but according to our definition, that gasoline has the ability to do something. It has the ability to do some work. It can drive the car 350 miles. It can go fast. It can go slow. It can cause the car to climb hills. It can take you to the grocery store and back. But of course, you have to release the potential energy in terms of burning it. And of course, that's essentially what happens in your engine is the energy starts to burn, and that's where the potential energy is released and is allowed to do something. So two similar problems here. This block has potential energy, but I had to release it and allow it to crush the can. The full gas tank has potential energy, but I had to release it in terms of burning before I would see that action or the result happen. So that's potential energy. Kinetic energy, pretty cut and dry, 1/2 mv squared, energy of motion. Potential energy, a little bit more confusing ramifications, and in another video coming up, I'll describe 2 or 3 very specific potential energies and their mathematical and physical definitions so we can use them in problems.